Welcome back. This is part 2 of chapter 12. In chapter 12, we're looking at small bodies of the solar system, asteroids, comets, and dwarf planets. And in this part 2 video, we will look at asteroids. And here we see on the left-hand side of the screen, 2 asteroids. This one is on the upper left, typical of what asteroids look like, just irregular shapes. The largest ones are rounded. And we're also in chapter 12 talking about other small bodies such as comets and dwarf planets. But for now, we're looking at asteroids. What are asteroids like? Well, here is a collection of various pictures of asteroids taken by various space missions. And the largest asteroid is Ceres, and it was this picture taken by the Dawn mission. And the second largest is Vesta. And so you can see their curvatures, and this picture is just to show you some size comparisons. But again, Ceres and Vesta are the 2 largest ones, and you can see some of these other ones. Of interest, these 2 are interesting, Ida and Dactyl. Ida and Dactyl, even though this whole slide here is a conglomeration of many pictures, Ida and Dactyl go together. Dactyl is a very tiny asteroid that's actually in orbit around Ida. Asteroids are cratered and generally not round. There's really only three, the 3 largest ones that are round, Ceres and Vesta being 2 of those, but usually they are not rounded, again, irregularly shaped rocks. Here is Vesta as seen by the Dawn spacecraft, and it is rounded, but when I say round, I don't mean spherical. It's more of an egg shape. Vesta is much wider across the equator than it is tall, and you can see the equatorial view. And it says, in part because a huge impact gouged out a crater near its south pole. Here is the largest asteroid, which is also classified as a dwarf planet. It's called Ceres. It's in the asteroid belt. And here we have a crater with a bright spot. It says a mysterious bright spots on this crater floor might be ice, salt, or something else altogether. So we're going to need further investigation to see what exactly that is. Right here, on the lower right of the picture of Ceres, a mountain 4 kilometers tall rises above otherwise bland surroundings. Here's a picture you saw in the previous video. The children gathered around meteorites. And so we're going to look at, what do meteorites tell us about asteroids? Remember that a meteorite is a piece of rock that has fallen from space. So we can explore asteroids by finding them as the remnants have fallen onto the Earth. We also find meteorites, not just from asteroids, but that are remnants of the Moon and Mars. They're very rare, but sometimes rocky material gets blown from Mars or the Moon and finds its way across space and ends up on Earth. We can tell that they're from the Moon or Mars because of the different geologies. An asteroid chemically, geologically is different from the Moon, which is different from Mars. And so it is an inexpensive, a cheap, but very slow way to acquire Moon rocks and Mars rocks, just to wait for them occasionally to fall to the Earth. Most asteroids are in the asteroid belt. And so here we see the orbits of Mercury, Venus, Earth, and Mars. And then a greater distance out is Jupiter. Remember, Mars is about 1.5 astronomical units from the Sun. And then Jupiter is 5 astronomical units. And so in there, in the middle, and it's got some width to it, but is the asteroid belt. And somewhere there in the asteroid belt is Ceres and Vesta, the 2 largest asteroids. But also remember that there are other asteroids. There are the Trojan asteroids that are 60 degrees in front of Jupiter, roughly 60 degrees. It's a swarm that takes up some space, and roughly 60 degrees behind Jupiter. And then there are some near-Earth asteroids that are all contained within Mars's orbit. But most of the asteroids are in the asteroid belt. Let's talk about why is there an asteroid belt? Rocky planetesimals between Mars and Jupiter did not accrete into a planet. So we think back to chapter 8 when we talked about the formation of the solar system, and planetesimals formed into Mercury, Venus, Earth, and Mars. Those were the rocky planetesimals. And Jupiter, Saturn, Uranus, and Neptune started out as rocky planetesimals and then gathered hydrogen compounds and hydrogen helium. But think of the asteroid belt as a planet that was trying to form, but it had gravitational tugs between the sun pulling in one direction and Jupiter pulling in the other direction. And Jupiter, because of its great mass, had a lot of gravitational tug. And there just wasn't able to be a stable orbit enough for a planet to form. And so it just was left as these planetesimals that never came together. Jupiter's gravity, through influences of what's called orbital resonances, stirred up the asteroid orbits and prevented their accretion into a planet. Now, getting more specific into it, asteroids in orbital resonance with Jupiter experience periodic nudges. And here we have on this graph, this is distance from the sun. So we start with 0, that being where the sun is. Here's Earth at 1 astronomical unit. Here is, let's go up to the top. 2 astronomical units, 3, 4, 5 is where Jupiter is. And those correspond to, down on the lower horizontal axis, the orbital period, 1 year, 2 years, and Jupiter is at 12 years. The idea of orbital resonances is that if a planetesimal had some simple fraction of Jupiter's orbital period, which is 12 years. So that would mean a quarter of 12 years is 3 years. A third of 12 years is 4 years. Then it especially would have been nudged one way or the other, either pulled towards Jupiter or pulled towards the sun. But what we see is that there are these gaps in these asteroid belts. So at 1/4 of 12 years, the things that would have been at that distance, there's a gap for no stable orbits. And at 1/3 of 12 years, another gap. And then you can see at 2/5, 3/7, and 1/2, we see those gaps. So the upshot of this is we have the asteroid belt that is from covering these distances, having these different orbital periods, but there are these gaps where stable orbits could not occur. So what it says in the graph, gaps occur where asteroids would have orbital periods that are simple fractions of Jupiter's 12-year period. For example, asteroids here would have orbital periods that are 1/3 of Jupiter's orbital period, or about 4 years. So in our quick look at asteroids, what have we learned? What are asteroids like? They are rocky, small, usually irregularly shaped, think of like potatoes, leftovers from the era of planet formation. Why is there an asteroid belt? Orbital resonances with Jupiter prevented planetesimals between Jupiter and Mars from forming a planet. And that is your quick study of asteroids. Have a great day.